like the quantilier is up and running. Hi. So AQUA is Advancing Quantum Architecture. We founded the AQUA group at SFC in 2007, and ever since we've been working on 4 separate research themes. We've been working on quantum computing, quantum communications, meaning quantum internet, quantum education, and quantum community. We've got projects in all these different areas. Some of these are on algorithms for quantum computing. Some of them are for software tools, including things like compilers. We've done quite a lot of work on quantum error correction. That's QEC there. We work on quantum internet, including a type of advanced networking that we call graph state quantum networking. And we also work on what we call NISQI, noisy intermediate scale quantum internet. For education, we work on both fundamental education for how to take people as complete beginners, and also on intermediate education, how we take people essentially to the leading edge of a particular topic, whether it's quantum computer architecture or whether it's quantum internet. And ultimately, we believe in belonging to a community and developing interest in quantum computing and quantum communication from people throughout the world. So come join us. There's a lot of exciting work going on.
Hi, everybody. I'm Michal. I'm a postdoc.
Hello, everyone. I'm White. So I'm a PhD student second year, and also the KG leader, which means I'm a student leader for this group. Nice to meet you.
Hello, everyone. My name is Sara, and I'm a PhD student third year. Nice to meet you.
Okay, I'm Kokori. I'm a second year of master's student. Nice to meet you.
So what we're doing for the basic wrinkle is one of our research projects is we're developing online courses for undergraduate quantum education. And so the particular one we're looking at right now is a course we developed that we released in March called From Classical to Quantum Light. So it consists of 15 lessons, and each lesson consists of several videos. Those videos are available on YouTube. So today we're going to look at one of those lessons where each of the students in the group watched a set of videos, and they're asking questions about the content and also helping us criticize the content and see what's working well and what's not. So
the first question is, let's see. Yeah, I think in the lecture there's a Brewster angle and that allows us to like polarize some photons, or I guess if I remember correctly. So is that possible to use it like polarize the qubit? That's the first question.
I think that's a very good question. And in a way, yes, but you have to be careful in what you mean by polarizing a qubit. So here I'm assuming that you are encoding the qubit in the polarization degree of freedom, either horizontal or vertical, something like that. And so what Brewster angle tells you is at that angle, certain polarization will not get reflected. It will just pass through into the material. So in that way, it filters out photons of certain polarization. So it's not in a way that you fire a qubit at some optical element and then change its polarization. It's just that it will split if it's a beam of photons, it will split them into those which are polarized in a certain way. Only those get filtered and they go pass into the material. And if you have a single photon, then it will have a chance to go through. So it's more of a filtering rather than, you can arbitrarily polarize the qubit, but you get the right meaning, yes.
So today I'm going to talk about the paper called Quantum Simulation with Hybrid Tensor Networks.
So for example, if you have n legs sticking out attached to a single ball, or in this case, Shingi used the rectangle because it would be difficult to have all of them coming out nicely in one direction. That's a rank n tensor, but in this context is used to represent a n-qubit state.
So I'm Sri, and this is my status update for this week. And so what I'm going to talk about this week is going to be a recap of what I set out to do, what I said I was going to do last week, and then what I'm currently working on.
Now, the trick when using Grover in this iterative fashion is the fact that Grover misbehaves if you don't run it knowing how many of the states have the answer that you're looking for. And so if there are 0 states that meet your criterion, or if half of the states meet your criterion, then Grover is just going to misbehave and give you a mess. And the trick is figuring out how to distinguish that from a real answer.